Hello friends, I welcome you all to my channel. Today I have taken a very simple question from trigonometry. In a triangle ABC, it is given 3 sine A plus 4 times cos B is equal to 6, whereas 4 times of sine B plus 3 times of cos A is equal to 1. You have to find the angle C. See the question? We have to find the angle C when AB trigonometric ratios are given. So we need a simple basic knowledge of trigonometry, that is sine square theta plus cos square theta. The result is always 1 for theta is any angle. So 3 sine A plus 4 times sine B cos B equal to 6. So I'll make square both the sides. Then it will be 9 times square A plus 16 cos square B plus 2 into 3 into 4, 24 sine A cos B is equal to 6 square is equal to 36. Coming to second expression, 4 sine B plus 3 times of cos A is equal to 1. Same procedure, I'll square both the sides. I'll get 16 sine square B 9 cos square A plus 24 sine B cos A is equal to 1. Now I add both the equation and I'll prove them taking 9 square A being with 9 cos square A plus 16 cos square B plus 16 sine square B plus 24 sine A cos B plus 24 I can take common, sine B cos A is equal to 37, 36 plus 1, 37. Now 9 sine square A plus cos square A will give us 1, 16 cos square B plus sine square B, that, and next I'll apply formula for trigonometry. Sine A cos B plus cos A sine B is nothing but your sine A plus B equal to 37. So in the next step, I'm getting 9 into 1, 16 into 1, 16 plus 24 times sine A plus B is equal to 37, or 24 sine A plus B is equal to 37 minus 16 plus 5, 25, that will be 12, or sine A plus B is equal to 12, 24, that will be half. So sine A plus B is equal to half. Next, in the triangle ABC, angle A plus angle B is equal to 180 minus c, because three angles makes 180 degree. So we will take sine function both the side, then sine a plus b is equal to sine of 180 minus c, that is nothing but your sine c. This implies that sine of c is equal to half, and half means we know that this is sine 30 degree or pi by 6. So angle C is 30 degree, and if the answer should be in radian, it will be pi by 6. Pi is 180 degree or pi by 6. So angle C is 30 degree. I hope you liked the answer. Today I have taken a trigonometry question from Math Olympiad base. The question is, prove 1 plus tan 1 degree multiplies 1 plus tan 2 degree plus 1 plus tan 3 degree up to 1 plus tan 44 degree multiplies 1 plus 45 degree is equal to 2 raised to the power 23. So this portion we can do, that is 1 plus 1, that is 2. And what about others? So for this, let me start in this way. I am writing 1 plus tan k degree. So that is equal to, I'll write 1 plus sine function of k degree plus cosine k degree. Again on simplifying, I'll get cos k degree plus sine k degree. So the numerator I'll try to get in sine function. What I'll do, I'll multiply 1 root 2 and 1 over root 2 cos of k degree plus 1 by root 2 sine of k degree. That will be cos k degree. In the next step, square root 2, 1 over root 2, I'll write your sine 45 degree cos k, and next one I'll write cos 45 degree and sine k. That will be, the new denominator is cos k. So this will be root square root 2 sine of 45 degree plus k, because we know that sine a cos b plus cos a sine b is equal to sine a plus b. In the next step, again I'll try to get sine function as cos function. How to do it? I'll write square root 2 sine 45. I'll write as, this is 90 minus 45 minus k. Do we know that sine 90 minus theta is equal to cos theta? So I'll write cos 45 minus k. So I started from 1 plus 10k degree. This is equal to square root 2 cos 45 minus k cos k. So next I'll write 1 plus tan 45 minus k. So that will be 1 plus sine 45 minus k or cos 45 minus k. In the same way it will be cos 45 minus k sin 45 minus k cos 45 minus k. Proceeding in the same manner, I'll write square root 2. This will be sin 45 plus 45 minus k cos 45 minus k. So sin 90 minus k, it will be ultimately cos k cos 45 minus k degree. So I am getting a very interesting expression now. 1 plus tan degree is equal to right hand expression, and 1 plus tan 45 minus k is equal to this expression. I'll multiply these two. 1 plus tan k degree into 1 plus tan 45 minus k degree. This will be square root 2 cos 45 minus k cos k into cos k over cos 45 minus k degree. So you'll see that these four terms are cancelled with each other. So ultimately we are getting 1 plus tan k degree multiplies 1 plus tan 45 minus k is equal to square root 2 multiplies square root 2 is equal to 2. So now coming back to the question. 1 plus tan 1 degree plus tan 2 degree plus tan 3 degree of 2 plus tan 43 degree plus tan 44 degree and 1 plus tan 45 degree. No need of writing, we know that this will be 2, tan 45 is 2. So I'll take them as pair 1 with 1 plus 44. So 1 plus tan 1 degree is tan 44 degree. Next 1 plus tan 2 degree plus tan 43 degree. So ultimately 3 will go with 42 and 1 plus tan 22 will go with 1 plus tan 23. Of course 1 plus tan 45 is 2. I am replacing by 2. This gives you 2. Next pair gives 2. So we'll go how many times? Here it will be 22 times. Up to 22 times. Another 1 plus tan 45 degree is equal to 2. Because 1 plus tan 45 is 1. So this will be 2 multiplies how many times? 23 times. So 222 into 2, that will be 2 raised to the power 23. So this will be the proof. Evaluate ln tan 1 degree plus ln tan of 2 degree plus ln tan of 3 degree up to ln tan of 89 degree. So applying the concept of logarithm, ln A plus ln B can be written as ln AB to any base. So ln, I'll write tan 1 degree, tan 2 degree, tan 3 degree, tan 88 degree, and tan 89 degree. This can be simplified as tan 1 degree, and tan theta is same as your cot 90 minus theta, or tan 90 minus theta can be written as cot theta, and tan theta multiplies cot theta is 1. So tan 1, tan 89, I'll write as cot 1, tan 2, this is multiplication, tan 2 degree, and tan 88 degree can be written as cot 2 degree, so on up to tan 44 degree into cot 44 degree, and tan 45 degree be different. So tan 1 into cot 1 multiplication is 1, this is 1. So this will be ln 1 multiplies 1 up to 22 times here, and tan 45 is 1, we know. So this is ultimately tan ln 1. ln 1 is 0, we know. Question is solved in the period 0 to 2 pi, both are included. Logarithm of 1 plus cos x base square root 2 times of sin x is equal to 2. So if you recall the concept of logarithm and exponential, we know that if a raised to the power b is equal to c, that means logarithm of c base a is equal to b. So here your base is equal to square root sin x, and logarithm of 2, that means base power 2 is equal to 1 plus cos x. So I am converting this as exponential function. So this implies that square root of sin x whole power 2 is equal to 1 plus cos x. Since I have to solve it, find the value of x, so I am simplifying this. It will be 2 sin square x is equal to 1 plus cos x. The next line we will convert the sin square as cos square. So 1 minus cos square x is equal to 1 plus cos x. On further simplification, it will be 2 minus 2 cos square x is equal to 1 plus cos x, or it will be 2 cos square x plus cos x minus 1 is equal to 0. On splitting the middle term, 2 cos square x plus 2 cos x minus cos x minus 1 is 0. So this gives me two factors. One is 2 cos x minus 1 and cos x plus 1. So I'm getting there are two values of cos x. One is either 2 cos x is equal to 1 or cos x is equal to half. From the second factor, cos x is equal to minus 1. Now let us check the solution, whether both will be the solution or anything will be rejected. Coming to first one is cos x is equal to half. Cos x is equal to half and the value is x is in between 0 to 2 pi. We know this is half is either pi by 3 or it will be positive in the fourth quadrant, that will be 2 pi minus pi by 3. 2 pi minus pi by 3 it will be, or it will be negative pi by 3. These are the two values. Now if we analyze this logarithm, root 2 sin x into 1 plus cos x is equal to 2. Here this pi by 3 will satisfy this equation, but this will not satisfy because again this sin x will be minus pi by 3 will be negative, so it is discarded. This we can write minus pi by 3 or we can write 2 pi minus pi by 3. That is also fourth quadrant, that will be 5 pi by 3. That is also rejected because sin x will be negative at the time. Now coming to cos x is equal to 1. If cos x is equal to negative 1, cos x is equal to negative 1, you will put in this logarithm definition. It will be 1 minus 1, that will be 0. We know that logarithm of 0 to any base is not defined. Not defined. So cos x is equal to negative 1 is rejected. Then what is the final solution? Final solution is only pi by 3. Equal to pi by 3 is solution. So the question is, solve 1 plus a square over twice a whole power x minus 1 minus a square over 2a whole power x is equal to 1. So your trick is only to divide each term with first term. That means 1 plus a square by twice a whole power x. So this will, first term will become 1. Second term will become 1 minus a square by twice a whole power x over 1 minus plus a square by twice a power x. And here it will be 1 over 1 plus a square by twice a power x. If we simplify this will be cancelled. Then 1 minus, this will be 1 minus a square over 1 plus a square to the power x is equal to twice a by 1 plus a square twice to the power x. Or on rearranging, I'll get twice a 1 plus a square whole power x plus 1 minus a square by 1 plus a square whole power x is equal to 1. So now we need some critical thinking. So we have to find a similar formula or relate this with the trigonometry. If I take a is equal to tan theta by 2, a as tan theta by 2, we know these two formulas. One is 2 tan theta by 2 or 1 plus tan square theta by 2 is equal to sine theta, and 1 minus tan square theta by 2 by 1 plus tan square theta by 2 is equal to cos theta. So these two formula are needed here, and you must be knowing this or recalling. So in place of A, I'll put tan theta by 2. Here this will be 1 tan theta by 2 whole square. So first term is becoming your sine theta. This is becoming sine theta. Putting A is equal to tan theta by 2. So this will become sine theta power x plus second term is becoming cos theta power x is equal to 1. The only thing you have to take care, you have to replace this one or substitute these values. Then only you should know this value. Then only you can solve it. If you don't recall, please note down and learn. So sin theta power x plus cos theta power x is equal to 1. So this is a very familiar equation to us. This is only possible. Yes, you are correct. Your guess is correct. X should be 2 because we know that sin square theta plus cos square theta is always 1. So x is equal to 2 is solution. It does not depend on the value of A. So let 0 degree is less than theta less than 45 degree. That means theta is in between 0 to 45. Arrange T1 term 1 tan theta power tan theta, T2 tan theta power cot theta, tan 3 cot theta power tan theta, and T4 cot theta power cot theta in decreasing order. So four terms are given. We have read the question. Now theta is in between 0 to 45 degree. So we first will analyze what is the value of tan theta and cot theta in this interval. We know that the value of tan theta is always greater than 0, less than 1 in this interval because tan 0 is 0, tan 45 is 1. So 0 to 1, it increases from 0 to 1. But cot theta is in this interval, it is always greater than 1. So cot theta is bigger than your tan theta. And also we know that if base remains same, a x1 is greater than a x2 power x2 if x1 is greater than x2 when a is greater than 1. If this base is greater than 1, then ax to the power x1 is greater than a power x2. But if a is less than 1, a is a fraction, then not fraction, it is less than 1 value, then a power x1 will be less than a power x2. For example, you are taking 3 power 2 is greater than 3 power 1, correct? But if I take 1 by 1 over 3 power 2 and 1 by 3 over power 1, so this will be less, this will be greater. This is the same thing here. So first I am comparing T3 and T4. T3, T4, in T3 and T4, T3 has the base cot theta which is greater than 1. T4 has also cot theta, but here the power is greater than 1, but tan theta is less than 1. So cot theta is greater than tan theta, cot theta is greater than tan theta, and cot theta is greater than 1. So T4 is greater than T3. T3 is less than T4. So these have 2, 3 and 4 are the same base, so we compared. Now I'll come this one, T1 and T2. They have the same base and cot theta is greater than tan theta, but tan theta, the value base is less than 1. As I have given an example. So tan theta, T1 is tan theta, power tan theta, and T2 is tan theta power cot theta. Cot theta is greater than tan theta, and the value of tan theta is less than 1. So that means here T1 is greater than T2. So we got a relation to T4 greater than T3 and T1 greater than T2. Next, I'll compare out of these two group, one with one. So I'm comparing tan T2 and T3 or T1 and T3. Any one you can compare. T1 is tan theta, and I'm comparing T3 is equal to cot theta to the power tan theta. So they have same exponent. Tan theta and cot theta is greater than tan theta. So certainly T3 will be greater than T1 because they have same base exponent c to the power b. Here c is greater, so c power b is greater than a power b. So T3 is greater than T1. Now from these three, T4 greater than T3, T1 greater than T2, T3 greater than T1. So from all this we can write T4 greater than T3 greater than T1 greater than T2. This is the solution. All 3x minus x cube over 1 minus 3x square is equal to square root 3. So let's take x as your tan theta or tan alpha, any value. So when x is equal to tan theta, 3x minus x cube over 1 minus 3x square. I am replacing x as tan theta. So this will be 3 tan theta minus tan cube theta over 1 minus 3 tan square theta. This is nothing but, you will recall, this is tan 3 theta. So substituting in the equation, the left hand side become as your tan 3 theta. So tan 3 theta is equal to root 3. This is a trigonometric equation now. We know how to solve it. Square root 3 is nothing but your tan pi by 3, 60 degree. Tan 60 degree is equal to root 3. So tan 3 theta is equal to tan pi by 3. Now coming to solution of trigonometric equation tan, if tan theta is equal to tan alpha, then theta is equal to n pi plus alpha when n is an integer. This gives us the value 3 theta is equal to n pi or k pi plus pi by 3 when n is an integer. So what will be theta? Theta will be just dividing. It will be n pi over 3 plus pi by 9. The answer. And what about x? X I have taken tan theta. So x is equal to tan n pi by 3 plus pi by 9 when n is an integer. Find n if 1 over sine 45 degree multiply sine 46 degree plus second term is 1 over sine 47 degree multiply sine 48 degree up to last term is 1 over sine 133 degree and 134 degree is equal to it equals to 1 over sine n degree. You have to find the value of n. So if you observe the each term, this difference is your only 1 degree. That means if I'll take a general term, here 47, 48, then it will be, the denominator will be, if I'll take any general term, let it be defined by tx, then it will be 1 over sine x degree and sine x plus 1 degree. This I'm converting in this way. I'll divide a sine 1 degree as well as multiply sine 1 degree in this term both in the numerator and denominator. I'm multiplying and dividing. Now the question is why? Because I want to write the denominator in numerator in term of denominator. So any term can be written as 1 over sine 1 degree. The sine 1 can be written as sine x plus 1 degree minus x degree. In the next term, I'll expand this numerator using the formula sine a minus b is equal to sine a cos b minus cos a sine b. So this will be sine x plus 1 degree cos x degree minus cos x plus 1 degree multiply sine x degree, and I'll convert this into 2. With both, I'll write this term. First term, these two will be cancelled, and the second, the other one will be cancelled. So I'm getting this term as 1 by sine 1 degree into cos x by sine x, it will be cot x degree, and cos x plus 1 by sine x plus 1 is equal to cot x plus 1 degree. Now I am going to each of the term. So first term is 1 over sine 45 degree multiply sine 46 degree can be written as 1 over sine 1 degree. Here x is equal to sine 45. So it will be cot and x plus 1 will be 46 degree. So what will the next term? Next term is 1 over sine 47 degree sine 48 degree. This will be 1 over sine 1 degree cot 47 degree minus cot 8 degree, 48 degree. So now taking the sum. So the sum is, it was the question, 1 over sine 45 degree, sine 46 degree plus sine 47 degree, sine 48 degree sine 89 degree, sine 90 degree. In between this term will come. And the last is sine 133 degree into sine 134 degree. This is equal to 1 by sine 1 degree. I'll take outside. First term will be cot 45 minus cot 46, plus cot 47 plus cot 48 sine 18 cot 89 plus cot 90 plus cot 91 degree minus cot 92 degree, so on. And the last will be cot 133 degree minus cot 134 degree. Next, what to do? Or s is equal to sum is equal to 1 by sine 1 degree. Here cot 45 is 1. I can write this value. Next term is cot 46. I'll take with cot 134. So minus taking common, it will be cot 46 plus cot 134. Next, cot 47, I'll take with cot 134, 133. Next, cot 90, 89, I'll take with cot 91. And minus cot 90 will be single term. That means in between all the terms are accommodated. That means cot 48 will be 132, cot 49 will be 131, so on. So in the next step, sine 1 degree, cot 45 is 1. This will be become 0. Why? Cot pi minus theta, 180 minus theta is negative of cot theta. Means cot 134 is cot 180 minus 46. So that will be minus cot 46. So it will be cot 46 minus cot 46. This will become 0. Next term will be cot 47 minus cot 47. This will become 0. so on. Last term will be about 90, that will be 0. All the terms will be getting cancelled. Cot 89 will be minus cot 89, they will be cancelled. So S will be 1 over sine 1 degree into 1 minus 0, that will be 1 over sine 1 degree. And it is given to be, what is given? Given that it is sine n degree. So this will be 1 over sine n degree. So n is 1. So this is the solution. So let us see the question. It was such a big question. Many terms were there, but it is simplified to be 1 upon sine 1 degree. So this is the beauty of mathematics. Question is evaluate cos alpha, cos twice alpha, cos 3 times of alpha, up to cos 999 times of alpha, given that alpha is equal to 2 pi over 1999. So let's begin. Before that, let me thank all the subscribers of my channel to subscribe and motivating me, so that along with you I am also learning every day. So this product cos alpha, cos twice alpha, cos 3 times alpha up to this, let me take, this is the product as P is equal to cos alpha, cos twice alpha, cos 3 times of alpha up to cos 999 alpha. At the same time, I am taking the product of sine alpha, sine twice alpha up to sine 99 alpha as q. Then let me multiply this, take the product of p and q, and writing in order, I am sine alpha, cos alpha, again sine twice alpha, cos 3, cos twice alpha, up to sine 99 alpha and cos 999 alpha. And we know that this is a familiar formula, that is 2 sine alpha cos alpha is equal to sine 2 alpha. Similarly, if we can multiply 2 here, I'll get sine 2 into 2 alpha. And here I'll get sine. That means the term will be less, because this contains so many numbers and the product also. So how many terms are there? There are 999 terms. So I have to multiply 999 times. So ultimately left side will become 2 to the power 999 p times of q is equal to, multiplying 2, I'll get sine twice alpha. Here I'll get sine 4 types of alpha, and last will be sine 2 multiplied 999 gives me 1998 alpha. There will be 999 terms. So if we analyze each term, 99p times of q, here it will be, I am writing one more line, but I have to analyze this. So here somewhere I'll get sine 998 alpha. Oh, I made a mistake. Sine 2 alpha, sine 4 alpha, all the even numbers. Somewhere I'll get sine 998 alpha, 998 alpha. Next will be sine 1000 alpha. And last will be your sine 198 alpha. So after getting this term, then we'll apply the trick. What is it? From 1000 onwards, alpha onwards, I'll try to change it to make the smaller number or the previous number. How to do this? I'll apply the trick that sine theta is equal to negative of sine twice pi minus theta. Because twice pi minus 360 minus theta, we are in third quadrant where sine is negative. So negative of negative sine theta is equal to your cos theta. Is equal to sine theta. So I'll change this 1000 alpha. How to change it? Sine 1000 alpha, I'll write sine twice pi minus 1000 alpha with a negative sign. Similarly, next one in this fashion. So now again, writing the product. So 2 to the power 999 p times of q is equal to sine 2 alpha, sine 4 alpha up to sine 998 alpha. Now we'll change all the terms. So first one will be negative sine 2 pi minus 1000 alpha. Next will be sine 2 pi minus 1002 alpha, because your next term will be your 1002 up to minus sine 2 pi. I'm writing last term now, 1998 alpha. If you think for the last one, it will be negative sine 2 pi minus 1996 alpha. So I have written here the trick I applied here. Next is I will go for another trick. What is that? See, negative sine pi minus, next I will apply the formula for the value for alpha. What is alpha? Alpha is 2 pi over 1999. So 2 pi minus 1000 pi over 2199. 2 pi, it will be 2 pi. It's not 1 pi. 1000 into 2 pi. So from these two, I'll take 2 pi common. Here I'll get 1 minus 1000 over 1999. This will be negative sine twice pi into, simplify this, 1999 minus this, it will be 999 over 1999. So it is very, seems to be complicated, but it's not complicated because immediately I'll get 2 pi over 1999 is equal to alpha. So this is negative sine 999. 2 2 pi over this is equal to alpha. So negative sine 2 pi minus 1000 alpha became your negative sine 999 alpha. So what will the next number? Next number will be 2 pi minus this should be, let me write again, 2 pi minus your 1002 into 2 pi over 1999. Taking 2 pi common, I'll get 1 minus 1002 by 199. That will be your 997 into 2 pi by 1999, which can be written as alpha. So this will be 997 alpha. So now writing the whole thing. We have understood now. So what about this last one? Let me write last one once. 2 pi minus 1998 alpha is equal to 2 pi minus 1998 into 2 pi over 1999. So taking 2 pi common, 1 minus 1998 over 199, that will be 2 pi, only alpha will be there. So this will be only alpha. So last term will be negative sine alpha. So writing the whole thing now, this will be sine 999, 997, so on, last will be alpha. So 2 to the power 999 p times of q is equal to sine twice alpha, sine 4 times of alpha, up to sine 998 alpha. Next is becoming negative sine 999 alpha. Then your negative sine 997 alpha. Next up to sine negative sine alpha. So how many terms are there here? Here are even number terms. So it will be positive. So 2999 multiplies p cube is equal to sine alpha, sine twice alpha, sine 3 times of alpha, sine 4 times of alpha, up to last is sine 999 times of alpha, which is nothing but your q. So interesting. So twice 2 to the power 999 p multiplies q. I am getting the whole right side as your q. So what will be p? P is equal to 1 over 2 to the power 999. This is the result of this question. I hope you have enjoyed. Prove that 1 over sine 1 degree and sine 2 degree product plus 1 over product of sine 2 degrees and 3 degree. Next will be 1 over sine 3 degree multiply sine 4 degree up to 1 over sine 89 degree and sine 90 degree is equal to cos 1 degree over sine square 1 degree. So you will observe each term This sine 1, sine 2, the difference is 1. Here sine 2, sine 3, the difference is again 1. Here also 1. So let me write a general expression, or nth term will be 1 over sine n degree multiply sine n plus 1 degree. So to simplify this, what I am doing, I am taking what will be sine n 1 degree in term of n and n plus 1. Sine 1 degree can be written as sine n plus 1 degree minus n degree. So that it will simplify, it will give you 1 degree. Now if you will expand this using the formula, I'll get sine n plus 1 degree cos n degree minus cos n plus 1 degree into sine n degree. So if here we are getting this values in terms of the denominator. So observing this, what we will do, we will multiply a sine 1 degree both in the numerator and denominator. Sine 1 over sine 1 degree sine 1 degree upon sine n degree into sine n plus 1 degree. What I am writing, I am simplifying the nth term. Simplifying n term by multiplying 1 sine 1 degree in both numerator and denominator. Then this will be 1 over sine 1 degree, and here will be sine n plus 1 degree cos n degree minus cos n plus 1 degree multiply sine n degree whole upon sine 1 n degree into sine n plus 1 degree. On further simplification, a n nth term if this, if I'll divide into two terms, so it will be sine n plus 1 degree cos n degree over sine n degree sine n plus 1 degree minus cos n plus 1 degree sine n degree sine n degree into sine n plus 1 degree. In the first term, we'll get these two terms cancelled, and here the other two is cancelled. So I'm getting nth term is equal to 1 over sine 1 degree. Here will be cos n over sine n. I'll get cot n degree minus cot n plus 1 degree. So next I'll go for telescopic sum of all the terms. That means if I'll write A1 is equal to cot 1 degree minus cot 2 degree. Of course, over sine 1 degree is there. Get A2 is equal to 1 over sine 1 cot 2 degree minus cot 3 degree. Third term will be 3 minus 4. The last term will be cot 89 minus cot 90. So now I am evaluating the whole question. Question is given us as 1 by sine 1 degree, sine 2 degree plus 1 over sine 2 degree, sine 3 degree, and last was sine 89 degree, 90 degree. So we multiplied 1 over sine 1 both in the numerator and denominator. So in the first term, I got cot 1 minus cot 2. Second one, cot 2 minus cot 3. Last cot 1 will be cot 88 minus cot 89. And last will be cot 89 minus cot 90. The degrees, this is equal to if we take all the telescopic sum, I'll get 1 by sine 1 degree. It will be cot 1 will be left and there cot 90 will be left. We know the value of cot 90 is 0. So it will be cot 1 degree by sine 1 degree. Cot 1 means this will be cos 1 degree upon sine 1 degree. Again sine 1 degree is there. So the answer is cos 1 degree by sine square 1 degree. So we reached at the right hand side, hence proved. The question is, let a and b are real numbers such that sine of a plus sine of b is equal to square root 2 over 2. Cos of a plus cos of b is equal to square root 6 over 2. Evaluate sine a plus b. So let's start. So equation 1 is sine of a plus sine of b is equal to by 2. So if I'll square both the sides, I'll get sine square a plus sine square b plus 2 sine of a into sine of b is equal to 2 over 4. Similarly, second equation is cos of a plus cos of b is equal to square root of 6 by 2. So squaring both the sides, I'll get cos of square a cos square b plus twice cos a cos b is equal to 6 by 4. Now I'll add these two expressions. Adding these two, get sine square of a plus sine cos square a sine square b plus cos square b plus twice sine a sine b plus cos a cos b equal to 2 by 4 plus 6 by 4, that is 8 by 4. 8 by 4 is 2. So on simplification, we know that this gives us 1. This is again 1. So 1 plus 1, 2. Plus twice sine A sine B plus cos A cos B is equal to 2. And again we'll recall the formula. This is nothing but your cos A minus B. So shifting 2 to right side, it will become 0. So 2i is cos of A minus B is equal to 0. Or simply cos of A minus B is equal to 0. Next I'll multiply these two expressions, sine A plus sine B. How much it was? Square root of 2 over 2 and cos of A plus cos of B is equal to under root 6 by 2. Multiplying these two, multiplying both the equation. So when we multiply, it will give us sine of A cos of A plus sine of A cos B plus sine B cos A plus sine B cos B. It's equal to square root 12 by 4. Or sine A cos A, we can make into sine twice A, and sine B cos B, we can make 2i sine twice B if I multiply 2 in this. So I'll multiply both the left and right hand with 2. So multiplying 2, I'll get, this is sine A cos A plus sine B cos B plus 2i is sine B cos A plus sine B sorry, I have taken this one to make sine to be, this is left, so sine A cos B equal to multiplying 2, I'll get 2 square root 3 by 4. Again, I'm multiplying throughout 2. So all will be cancelled. I'll get square root 3. So this will be sine twice A plus sine twice B plus 2. This is nothing but your sine A plus B. This is sine A plus B. Of A plus B is equal to square root 3. Next, what to do? Next, I'll again put the formula for this. What is it? By sum and product formula, this will be 2 sine A plus B in multiplies cos A minus B plus 2 sine A plus B square root 3. Now you know the result because we have already got cos A minus B is equal to 0. We have got cos A minus B is 0. So if you substitute here, the first term will become 0. 0 plus 2 sine A plus B is square root 3. So this gives us sine A plus B is square root 3 over 2. So this is for the solution. Prove that the average of 2 sine 2 degree, 4 times sine 4 degree, 6 times sine 6 degree, up to 180 times sine 180 degree is equals to cot 1 degree. So this is a very interesting question. So immediately you must think that sine 180 is 0. So, but when we are calculating the average, the result is not 0. So let us proceed. So we know the mean and average. So how many terms are there? 1, 2, 3, 4 up to, it will be 90 terms will be there. It will analyze 2 degree, 4 degree, 6 degree up to 180 degree. So there will be 90 terms. So n is equal to 90 here. That means we have to prove that, to prove 2 times of sine 2 degree plus 4 times of sine 4 degree up to 180 times of sine 180 degree average divided by 90 is equal to cot 1 degree. Or this implies that to prove 2 times of sine 2 degree plus 4 times of sine 4 degree up to 178 times of sine 180 degree, because this will be 0, is same as 90 taking right side, 90 times of cot 1 degree. Or we have to prove, now I am multiplying sine 1 degree in both left hand and right hand. So it will be 2 times of sine 2 degree, sine 1 degree. I am multiplying sine 1 degree in each of the term, sine 1 degree, 178 sine 178 degree sine 1 degree is equal to cot 1 means cos 1 by sine 1. So when we multiply sine 1, then will be cancelled. That will be, I have to prove that 90 times of cos 1 degree. So this is the same, this is the another form of the question. So next, the critical thinking. So here I'll apply a formula because I am taking the nth term. Suppose this is kth term, that will be 2 times of sine 2k into sine 1. If I'll apply the formula 2 sine A sine B, this is nothing but your cos 2k minus 1 minus cos 2k plus 1. I am applying this formula to each of the term. So 2 sine 2 degree sine 1 degree, here I will take 2 common so that I will get 2 times of sine 4 degree and again sine 1 degree. Last will be, I will take 89 common so that it will be 2 times sine 178 degree and sine 1 degree. So of course I should write this one just after this step anyway. So we will apply this formula in all the cases. So first term will be cos 1 degree minus cos 3 degree. 2k minus 1, it will be 2 minus 1 cos 1, 2k is 4, 2 plus 1, that will be 3 degree. Second one will be 2 times of cos 3 degree minus cos 5 degree. So what will be the next term? It will be 3 times of cos 5 degree minus cos 7 degree, so on. So what will be the last but one? It will be 88 times cos 177, sorry, it will be 175 minus cos 177 degree, and the last term will be 89 cos 177 degree minus cos 179 degree. So you can write yourself and you can verify. We are getting with the formula, we are getting this result. Now this is the telescopic sum, we say. So if we will go on simplifying, this is negative cos 3 degree and here this is positive 2 cos 3 degree. So I'll get 1 cos 3 degree here, and the second term it is minus 2 cos 5 degree, and here I am getting 3 cos 5 degree, so I'll get 1 positive cos 5 degree. In the same way I'll get positive cos 7 degree, so on. Only the last one will be negative. So ultimate result is cos 1 degree plus cos 3 degree plus cos 5 degree, so on up to cos 177 degree minus 89 times of cos 179 degree, and before that certainly it will be cos 175 degree. This will be cos 175 degree. Next what? Next pairing. So cos 1 is cannot be paired, but cos 3 degree I'll pair with this. Why? Cos 3 degree plus cos 177 degree will cancel each other, because cos x is negative of cos 180 minus x. If you recall, cos 180 minus x is equal to minus cos x. So this will be nothing but your minus cos 3 degree. Minus cos 3 degree, so this will be cancelled. Similarly, cos 5 degree plus cos 175 will gives you 0, so on. And here somewhere I'll get cos 89 degree plus cos 91 degree. They will cancel each other, and last will be minus 89 cos, and 171 9 is nothing but your negative cos 1 degree, which will give you plus 89 1 degree. Let me explain again. Cos 179 is equal to cos 180 minus 1, so that will be negative cos 1, and negative cos 1 negative here, it will make it positive, and this is I applied in all the terms so that they are cancelling each other. Cos 177 is equal to negative cos 3 degree. Similarly, cos 91 is negative cos 89, so they will cancel each other. So ultimately at the last I am getting 1 cos 1 degree plus 89 times cos 1 degree, because cos 79 is same as cos 1 with negative signs and this negative negative positive. So this will be 90 times cos 1 degree. So I hope we got the result. So it is proved. Evaluate the product. The terms are 1 minus cot 1 degree, 1 minus cot 2 degree, 1 minus cot 3 degree, up to 1 minus cot 44 degree. So how to start? I am writing a general expression taking cot x degree or simply cot x. If I want to write to 1 minus cot x, then how to simplify this? I'll write 1 minus cos x over sin x, or this will be sin x minus cos x upon sin x. So if I'll multiply a square root 2 and divide a square root 2 in this 1 minus cot x, then I'll get 1 not 1. The numerator will be root 2 multiplies 1 by root 2 sin x minus 1 by root 2 cos x whole upon sin x. So what is the motive of doing this? I'll convert the above numerator to a sine function. How to do it? So root 1 over root 2 I can write cos 45 degree or pi by 4 minus this will be sine 45 degree into cos x upon sin x. So ultimately, if you will recall, this is a formula in sine, that will be sine x minus 45 degree whole upon sin x. So this is the final expression of 1 minus cot x is equal to square root 2 sine x minus pi by 4 or 45 degree upon sin x. So I'll write each of the expression given here. First is 1 minus cot 1 degree. So it can be written as square root 2 sine 1 degree minus 45 degree whole upon sine 1 degree. So this is nothing but your square root 2 sine minus 44 degree upon sine 1 degree. Sine minus 44, we know that it will be sine 44 and this negative I can take outside. Sine minus theta is minus sine theta, sine 1 degree. So let us write now 1 minus cot 2 degree. It will be root 2 into sine 2 minus 45 degree. 2 degree minus 45 degree over sine 2 degree. So this will be negative root 2 sine 43 degree upon sine 2 degree. So if I'll go on writing 1 minus cot 44 degree, it will be square root 2 sine 44 minus 45 degree over sine 44 degree. This is nothing but negative square root 2 sine 1 degree upon sine 44 degree. So here I am applying sine minus theta is minus sine theta. So let us multiply now what is given in the question, which we have to evaluate. 1 minus cot 1 degree, 1 minus cot 2 degree, up to 1 minus cot 44 degree. All the terms are here. So it will be, we are getting all square root, and these are how many terms? 44 terms. So 44 terms, 44 times our negative is multiplied, it will be positive. It is understood. And square root 2 is also multiplied in each of the things. So it will be square root 2 negative 1 multiplied by 44, square root 2 multiplied by 44, and I am getting here sine 44, sine 43 degree, sine 42 degree, so on, sine 3 degree, sine 2 degree, and sine 1 degree. And what about this denominator? Denominator is, first we started from sine 1 degree, next sine 2 degree, sine 3 degree, and last will be your sine 44, sine 1 degree, a 44 degree, not 1, 44 degree, sine 44 degree. So we are getting very interesting result now. The numerator is same as the denominator, so we can cancel all the things. It will become 1. So this will be positive, and square root 2 power 44 is nothing but your 2 power 22. So this is the result of or solution of this question. So when we are evaluating 1 minus cot 1 degree, 1 minus cot 2 degree, up to 1 minus cot 44 degree is equal to 2 to the power 22. I hope you have enjoyed. One equation for the algebra, we have to solve it, but the problem is the equation is x square plus 4x cube minus 3x whole square is equal to 1. X is a real number. If I expand this, I'll get an equation of power 6. So which is difficult for me to solve it. So I am thinking to use trigonometry. Let us check whether we are able to solve it. You can try using algebra also. If you are successful, write in the comment section. I welcome your feedback. So here I am applying trigonometry. That means I am taking let x is equal to xb cos theta. And before that, I should take care of what is the minimum and maximum value of cos theta. That is negative 1 to 1. So theta must be in between 0 to pi. It can be 0, it can be pi also. Let us check. So I am taking this interval from 0 to pi. It may be equal also, but I am not taking here. We may write also. So this expression becomes now cos square theta plus, now take care of this, 4 cos cube theta minus 3 cos theta is nothing but your cos 3 theta. So this is the formula we have to apply here. So then only I can get a simplified equation. So cos 3 theta whole square is equal to 1. So cos square theta plus cos square 3 theta is equal to 1. Next simplification. Next again I will apply formula 1 plus cos 2 theta 2 alpha is equal to 2 cos square alpha. From this, cos square alpha can be written as 1 plus cos 2 is alpha by 2. So applying this, I'll change this both the expression. First one will be 1 plus cos 2 theta over 2, and second one will be half, not half, 1 plus cos 3 multiplies 2 cos 6 theta by 2 is equal to 1. Or this will be half plus half cos 2 theta plus half cos 6 theta equal to 1. Or this equal to 1 plus half 1 cancel with 1, half cos 2 theta plus cos 6 theta is equal to 1. Is equal to 0 by 1. So this gives us cos 2 theta plus cos 6 theta is equal to 0. Next formula I am applying cos A plus cos B equal to 2 cos A plus B over 2 and cos of A minus B over 2. So applying for this, it will be cos 2 theta plus cos 6 theta is equal to 0, or that will be twice cos 2 theta plus 6 theta over 2 into cos of 2 theta minus 6 theta by 2 is equal to 0. This gives us cos 4 theta into cos minus 2 theta. We know that cos minus theta is same as cos theta, so this is equal to 0. So either cos 2 theta is 0 or cos 4 theta is 0. So to solve it, we have to take care of this interval. Theta is 0 to pi. So cos 2 theta is 0. That means 2 theta is equal to pi by 2. At pi by 2, cos 2 theta becomes 0, or it will be 3 pi by 2. 2 theta is equal to pi by 2 or 3 pi by 2. That means theta is equal to pi by 4 or 3 pi by 4. And what is x? X is equal to cos theta. This will be cos pi by 4 and cos 3 pi by 4. Either pi by 4 or it will be cos 3 pi by 4. Now taking the value of cos pi by 4 and cos 3 pi by 4, cos pi by 4 we know that 1 by root 2. So this can be written as root 2 over 2. If cos 3 pi by 4 I'll take, that will be x is equal to cos pi minus pi by 4. That will be negative of root 2 over 2. So from this first one I am getting x as plus minus root 2 over 2. Next coming to second one, cos 4 theta is equal to 0. Cos 4 theta is 0, that means theta is in between 0 to pi. So 4 theta is equal to, it can be pi by 2, it can be 3 pi by 2, it can be 5 pi by 2, it can be 7 pi by 2. So theta can be pi by 8, 3 pi by 8, 5 pi by 8, and 7 pi by 8. Then what about x? X is equal to cos pi by 8, cos 3 pi by 8, cos 5 pi by 8. Cos 5 pi by 8 is same as your negative of cos 5 pi by 8. Sorry, 3 pi by 8. And cos 7 pi by 8 is negative of cos pi by 8, because pi minus pi by 8 is equal to 7 pi by 8. So I can write plus minus pi by 8 plus minus 3 pi by 8. How to get the value of cos pi by 8? Cos pi by 8 is equal to root over 1 plus cos pi by 4 by 2. This is equal to 1 plus 1 by root 2 over 2 square root. So that will be root 2 plus 1 by 2 root 2. Now on simplifying, I'll get 2 plus root 2 square root by 2. And about cos 3 pi by 8, it is equal to square root of 1 plus cos 3 pi by 4, that will be square root of 1 minus 1 by root 2 by 2. It is simplified to 2 minus root 2 by 2. So what are the final result? Final result will be plus minus by 2, then plus minus root 2 by 2, because cos pi by 8 is this and cos 7 pi by 2 will be negative of this. So it can be plus minus. Similarly, here also plus minus. So it will be plus minus 2 plus root over by 2. So this is the value of x. These are the solution. Question is, if a, b, c, d be the numbers in the interval 0 to pi, sine of a plus 7 sine of b is equal to 4 times of sine of c plus twice sine of d. As well as it is given cos of a plus 7 cos of b is equal to 4 times of cos of c plus twice cos of d. We have to prove that twice cos a minus d is equal to 7 times of cos of b minus c. So this is very simple. So to get this proof, the function in AD, I'll take sine A and sine D to one side from equation 1. So from equation 1, I'll simplify by rearranging. So sine of A minus 8 times of sine of D. So if it is multiplied, it will be 8. Here it will be 4 sine C minus 7 times of sine B. The same way, this will become equation 1 by arranging, and equation 2 will be cos A minus 8 cos D is equal to 4 cos C minus 7 cos B. Now I'll square both the equations. So left hand side will become sine square A plus 64 sine square B minus 16 sine A sine B, and in the right side I'll get 16 sine square C plus 49 sine square B minus 56 sine B sine C. Now squaring equation 2, I'll get cos square A plus 64 cos square D minus 16 cos A cos D is equal to 16 cos square C plus 49 cos square B minus 56 cos C cos B. So I got this by squaring, then I'll add them. So I'll get sine square A plus sine square cos square A, these two, then 64 sine square D plus cos square D minus 16 sine A sine B plus cos A cos D. This is our left hand side, and on the right hand side we will get 16 sine square C plus cos square C plus 49 sine square B plus cos square B minus 56 sine B sine C plus cos B cos C. Sine square plus cos square is equal to 1. Sine square D plus cos square D will be 1. So 64 multiplies 1 is 64 minus 16. And this is nothing but our cos A minus cos D. Let me see the question once. A minus D. Yes, I'll write cos A minus D is equal to, right side I'll get 16, again multiplies 1, 49, this will be 1 minus 56 cos A minus D, B minus C. So this gives us 65 minus 16 cos A minus D is equal to, here 65 minus 56 into cos B minus C. So 65 cancel, negative negative cancel. So on the next line I'm getting 16 cos A minus D is equal to 56 cos B minus C, will be cancelling by 8. So twice cos A minus D is equal to 7 times of cos B minus C. Hence it is proved. Prove that 1 over cos 6 degree plus 1 over sine 24 degree plus 1 over sine 48 degree is equal to 1 over sine 12 degree. So let's proceed for the solution. Or to prove 1 over cos 6 degree plus 1 over sine 24 degree plus 1 over sine 48 degree minus 1 over sine 12 degree is equal to 0. I took all the terms to left hand side and I'll prove that this will be 0. Again, I'll arrange this to make two pairs so that it will be easy for me. So LHS, it is not 66 degree, 1 by cos 6 degree. With it, I'll take 1 over sine 48 degree and 1 over sine 24 degree minus 1 over sine 12 degree together. Let us simplify. So LCM will be cos 6 degree sine 48 degree. So in the numerator will be sine 48 degree plus cos 6 degree. Plus here LCM will be sine 24 degree sine 12 degree and sine 12 degree minus sine 24 degree. So here one thing to make an arrangement that cos 6 degree, I'll write this will be sine 90 plus 6, that will be sine 96 degree. That means the numerator I am making both the function as sine. So this will be sine 48 degree plus sine 96 degree. Cos 6 degree sine 48 degree. Here also I am making some arrangement. What is it? I am taking a negative sign outside so that it will be sine 24 degree minus sine 12 degree, sine 12 24 degree, sine 12 degree. Then we will apply the formula sine A plus sine B is equal to 2 sine A plus B by 2 to cos A minus B by 2. And for the second one in the numerator, I'll apply sine A minus sine B, that will be 2 cos A plus B by 2 and sine A minus B by 2. So our LHS will become now, applying these two formula, it will be 2 sine 48 plus 96, 144 divided by 2, that will be 72 degree, and cos 96 minus 48, 48 by 2, that will be 24 degree. Here it will be cos 6 degree and sine 48 degree, the denominator will be as it is. Here sin A minus sin B, it will be 2 cos 24 plus 12, 36 by 2, 18 degree, and sine 24 minus 12, 12 by 2, that will be 6 degree. So sine 24 degree and sine 12 degree, the denominator will be as usual. I will be for. In the next step, this will be 2 sine 72 degree cos 24 degree. Now time to change the denominator. Here I will apply the formula to sine twice a is equal to 2 sine a cos a. So I will apply for sine 48. So it will be twice sine 24 cos 24. To cancel then this numerator cos 24, I am doing all this. Here it will be 2 cos 18 sine 6 degree, and to cancel this sine 6 degree, I'll change sine 12 now. So it will be sine 24 multiplies 2 sine 6 degree cos 6 degree. Formula I have written the block. So in the next step, this 2 will be cancelled, and here sine 6 will be cancelled. So we will find the same term in the numerator and denominator. Is it same? We have to convert into same. Then only. So 2 to cancel, I need not write. So sine 72 degree into cos 6 degree and sine 24 degree minus cos 18 degree whole upon sine 24 degree into cos 6 degree. So in the numerator, just observe, one is sine 72, one is cos 18. So they are both same. Sine 72 degree is same as your sine 90 minus 18, that will be cos 18 degree. So I can write cos 18 degree cos 6 degree sine 24 degree minus cos 18 degree again sine cos 6 degree sine 24 degree. So what is the result? Result is simply 0 because they are same. So we have proved. So 1 over cos 6 degree plus 1 over sine 24 degree plus 1 over sine 48 degree minus 1 over sine 12 degree is equal to 0. Hence proved. Then prove that product of 4 cos square 9 degree minus 3 whole into 4 cos square 27 degree minus 3 equals to tan 9 degree. So let's begin. So here I'll take a help of a formula we have already learned. If you have not learned, no problem. You can note down today only. Cos 3 times of theta is equal to 4 cos cube theta minus 3 cos theta. So if you observe this 4 cos square 9 degree minus 3 is first term. If I'll multiply a cos 9 degree, I'll get a similar expression as right hand side here. So both in the numerator and denominator, I'll multiply a cos 9 degree. Then the numerator will be 4 cos cube 9 degree minus 3 cos 9 degree whole upon cos 9 degree, and the numerator will be cos 3 times of 9 degree, that will be 27 degree. over cos 9 degree. Now coming to the second term, 4 cos square 27 degree minus 3. I'll multiply cos 27 degree here, both in the numerator and denominator. So this will be 4 cos cube 27 degree minus 3 cos 27 degree whole upon cos 27 degree. That will be cos 3 times of 27. That will be cos 81 degree over cos 9 degree. Cos it will be 27 degree. So I'll multiply the two expression because LHS is equal to 4 cos square 9 degree minus 3 whole into 4 cos square 27 degree minus 3. The ultimate simplified result I got 27 degree over cos 9 degree multiplies cos 8 degree by cos 27 degree. Cos 27 cancelled. Now this will be cos 81 degree over cos 9 degree. Now see the right hand side, it is tan 90 degree. That means I'll convert this cos into sine. This is same as your sine 90 minus 81 degree by cos 9 degree. That will be sine 9 degree over cos 9 degree. Ultimate result is tan 9 degree, which is equal to RHS, right hand side. So hence the result is proved. So the question is, let ABC is an acute angle triangle. Prove that tan A plus tan B plus tan C equals to tan of A, tan of B, tan of C product. And B part is tan of B, tan of A, tan of C product is greater than equal to 3 square root 3. So first I am taking the first part. For this, we need two things here to remember or to recall. That is, in any acute angle triangle, that is, we know that A plus B plus C is equal to 180 degree, or we say pi. So if I take B plus C only, or A plus B is equal to 180 minus C, or pi minus C. Now, if I take tan function both the side, it will be tan of A plus B is equal to tan of pi minus C. So here we need to recall two formula. One is tan of A plus B, that is compound angle. So that is equal to your tan A plus tan B over 1 minus 10 times of tan of A, tan of B. And second formula is tan 180 minus theta is equal to minus tan theta. So minus tan C. Then I'll cross multiply. So tan A plus tan B equals to minus tan C times 1 minus tan of A to tan of B. In the next step, I'll get tan of A plus tan of B equals to minus tan of C plus tan of A, tan of B, tan of C. Now shifting your tan C to left hand side, I'll get tan of A plus tan of B plus tan of C is equals to tan of A, tan of B, tan of C. So this is a very simple question, but it is a use in many questions. For examples, here we'll give in part B. Let's see. So for second part, we have already proved this. That means for tan A, tan B, tan C, I can replace this one whenever is necessary. So here to prove tan A into tan B into tan C is greater than 3 times square root 3, I need another one formula that's equal to arithmetic mean of numbers is always greater than their geometric mean. So here I am taking three numbers. One is tan A, tan B, and tan C. So their arithmetic mean will be tan A plus tan B plus tan C divided by 3. And geometric mean is equal to cube root of, when there are two numbers, we take square root. When there are three numbers, geometric mean will be cube root. Tan A, tan B, tan C. Now applying this AM is greater than GM, I'm getting tan A plus tan B plus tan C over 3 is greater than equal to cube root of tan A, tan B, tan C. Cube root. So what is tan A plus tan B plus tan C? Now I can replace this one. This is same as your tan A plus tan B. Sorry. And 3 I'll shift to the right side. It will be 3 times of cube root of tan A, tan B, tan C. It's cube root. Now if I divide or take tan A, tan B, tan C to left side, I'll get tan A, tan B, tan C power 1 minus 1 by 3. The power will be 2 by 3 is greater than equal to 3. Now taking power both the side power 3, or directly I can write tan A, tan B, tan C is greater than 3 power 3 by 2. 3 power 3 by 2 is 27 square root, or this is your 3 root 3. This proves A, then B, then C is greater than equal to 3 root 3. I hope here. Let alpha equals to pi over 7. Show that sine square 3 times of alpha minus sine square alpha equals to sine of 2 alpha multiplies sine of 3 alpha. So I'm writing the formula we have to use here to find the result. First is, it is the formula from algebra, that is square of A minus square of B is equals to A plus B multiplies A minus B. So when I write sine square 3 times of alpha. This is same as your sine 3 alpha whole square, and this is sine alpha square. So this can be written as sine 3 alpha plus sine, not plus, yes, plus alpha whole into sine 3 alpha minus sine alpha. In the next line, I'm writing all LHS. Here sine 3 alpha plus sine alpha, I'll apply the formula sine A plus sine B, that will be twice sine A plus B by 2, that means A is 3 alpha plus alpha by 2 whole multiplies cos A minus B by 2, so 3 alpha minus alpha by 2 multiplies sine 3 alpha minus sine alpha. We will apply the formula sine A minus B, that will be cos A plus B by 2, twice cos A plus B by 2, so 3 alpha plus alpha by 2 multiplies sine 3 alpha minus alpha by 2. So in the next step, it will be twice sine 3 alpha plus alpha 4 alpha by 2, that will be twice alpha, and here 2 alpha by 2 is cos alpha, multiplies twice, here in the same way it will be cos 2 alpha multiplies sine alpha. So I'll arrange now 2 sine 2 alpha and cos 2 alpha together, twice cos alpha sine alpha together. Then again this can be written in simplified form, applying the formula 2 sine A multiplies cos A is equal to sine twice A. So first one will be sine 2 twice alpha, that will be 4 alpha, and second one will be sine 2 alpha. Now the result is ready. Why? Result is given sine 2 alpha multiply sine 3 alpha RHS, but sine, I am getting 4 alpha and sine 2 alpha. Is it wrong? No. Why it is cannot be wrong? Because sine 4 alpha is same as your sine pi minus 3 alpha, because alpha is equal to pi by 7 or 7 alpha is equal to pi. So here I'll write when alpha is pi by 7, sine 4 times of alpha can be written as pi minus 3 alpha multiply sine twice alpha. Sine pi minus theta is same as your sine theta. So sine 3 times of alpha into sine 2 times of alpha. I hope you enjoyed the result. Thank you for watching. Don't forget to subscribe if you have not subscribed. Like, share and comment down in comment section.